To begin, heat the hot plate to above 100 degrees Celsius. The solvent we'll be using is distilled water, which has a boiling point of 100 degrees. In order to save time, heat the hot plate above that temperature until the water is almost at its boiling point. While the water is heating up, measure the organic compound, in our case, impure benzoic acid. We are going to use between 2.8 to 3 grams of benzoic acid. We are then going to add either hot or cold distilled water to it. The amount of solvent, in this case water, to use should be slightly more than you'll need to dissolve the substance being purified when the solvent is hot. The initial water you add should be 20 milliliters for each 1 gram of organic compound. Therefore, we are adding nearly 60 milliliters of water to our impure benzoic acid. To mix the solution, we are going to add a magnetic stir bar to prevent bumping or rough boiling from occurring, which could potentially spill the hot solution. Be sure to slide the bar down the beaker instead of dropping it to prevent damage. Place the beaker in the middle of the hot plate alongside the nearly boiling solvent. Turn the magnet up slowly. Once the top of the mixture has collapsed in, do not turn it up any higher to prevent the solution from spilling. Using a pasture pipette, add the nearly boiling solvent until all of the organic compound has dissolved. The impurities in the compound will not dissolve, so if you add solvent and no more compound has dissolved, that is enough. If there's a layer of crystals or film on the top of the solution, treat these as impurities. Be careful not to add the solvent too slowly, as a lot of solvent can be lost the longer it is left nearly boiling. Once you have decided that no more solute is dissolving, add up to 25% of excess solvent to avoid working too closely to the saturation point. Remove the solution from the hot plate for about 1 minute to allow it to cool below the boiling point. Once you have waited 1 minute, add 0.8 to 1 gram of charcoal to the solution slowly. If done too quickly, or if the solution is too hot, an eruption can occur. Be careful not to add too much charcoal, as the product can be absorbed and filtration can be made more difficult. Place the now black solution back on the hot plate to mix and reheat. Once the solution has nearly reached its boiling point, keep it at this temperature for another minute to allow for the charcoal to completely mix, as well as for any crystals that had formed while it was cooling to redissolve. Charcoal is added to remove impurities. In this case, some of our impurities were colored red. Adding charcoal removed this coloration. Charcoal is able to do this because it contains a large amount of particles with a lot of surface area. This surface area binds to impurities through adsorption and allows for the impurities to be separated from the solvent through filtration.
To remove the charcoal and impurities, we'll be using gravity filtration. To prepare, place a fluted filter paper into a powder funnel, which sits on an Erlenmeyer flask. For directions on how to flute your filter paper, please see the link in our description. Be sure to use a powder funnel instead of the 60-degree funnel, as it has a shorter and wider neck. This prevents the solution from cooling, which can cause premature crystallization. Fluted filter paper is used to filter the filtrate before unwanted crystallization occurs due to the filtrate cooling off. Fluted filter paper increases the surface area that comes into contact with the filtrate, speeding up the filtration. It also reduces the amount of contact between the filter paper and the funnel, which helps prevent cooling from occurring. To preheat it, you can do one of two methods. Pour about 10 milliliters of boiling solvent through the filter paper, or put a bit of solvent in the flask and bring it to a boil. The vapors will heat and bathe both the filter paper as well as the funnel. Be sure to add enough solvent that the flask does not boil dry. Before filtering the solution, empty the flask of the boiling solvent. Try to keep everything hot to prevent premature crystallization from occurring. Do so by having the Erlenmeyer flask on the hot plate and placing the beaker containing the charcoal solution back onto the hot plate when you are waiting for the solution to filter through the fluted filter paper. Filter the black charcoal solution into the fluted filter paper slowly, little bits at a time. The filtered solution should be clear and colorless. If the filtrate is not colorless, a second round of charcoal treatment and gravity filtration is required. If there is still charcoal in the filtered solution, use a new fluted filter paper and refilter the solution. If there is excessive crystallization in the filter, there is either too much cooling occurring or you're working too close to the saturation point. If this occurs, add more hot solvent to the beaker in which the charcoal has been added and reheat to boiling. After all the filtrate is collected from gravity filtration, it should be placed on a flat surface, undisturbed, to cool slowly and thoroughly. This will allow for crystals to begin forming. If no crystals are forming, seeding can be used, which is when you use a glass stir rod to scratch the inside of the glass under the surface of the filtrate to promote crystal formation, providing sites for adhesion. You can also place the flask into a larger beaker with cold tap water to help the formation of crystals. Ice can also be added to the cold water to speed up the process even more. Gravity filtration is used to rid a solution of insoluble impurities before suction filtration is performed. Using suction filtration when removing impurities could result in rapid crystallization, which can cause the occlusion of impurities. In this lab, suction filtration is used when there are formed crystals in the solution which have been cooled and are wanting to be extracted. To begin the procedure of suction filtration, a Buchner funnel, neoprene adapter, filter flask, vacuum, and filter paper are needed. In this lab, we used a large Buchner funnel and neoprene adapter. The filter paper should cover all of the holes in the funnel without creeping up the sides. The Buchner funnel should be placed in a filter flask, and the filter paper should be dampened by the solvent to prep for filtration and ensure the filter paper stays in place. Secure the flask with a clamp to prevent an accident from occurring. The vacuum should be turned on and tested to make sure that it is sucking air and not blowing. Once this is done, the vacuum can be attached to the filter flask, and we are ready to begin filtration. In order to transfer a maximum amount of crystals from the Erlenmeyer flask, it should be swirled and poured quickly into the Buchner funnel in one motion. If an ice bath is used, make sure that no liquid from the outside of the flask drips into the funnel. Keep the vacuum connected until all the filtrate is collected. Cold solvent is then used to rinse the collected solid to remove any final impurities.